when you draw a kind of perfect snowflake shape and it looks like that, sorry, but that's just wrong. Hi, my name is Nina Marhandel. I'm a doctoral researcher at Leipzig University, and I talk about research in the Arctic, especially focusing on clouds and snow. And today's video is gonna be about one of my favorite topics, snowflakes. So let's get into it. I'll be answering questions like, why do snowflakes look like they do? How are they made? Is every snowflake unique? And why do I get really triggered by seeing these snowflakes drawn like that? We are going to tackle some basics today, and then in the follow-up video I want to show you some really weird looking snowflakes. So I hope you learn some interesting facts today. Maybe once it starts snowing, I mean if it snows where you're from, you can bore your family and friends with those facts. I want you to picture a snowflake. Probably looks like something like that, right? But what if I tell you that's also a snowflake? And that, and that. So these are all different types of snowflake shapes. Scientists noticed quite a while ago that snowflakes look different. So in 1611, Johannes Kepler was probably the first one to describe snowflakes in a kind of scientific sense. Once photography was available and advanced enough, photographic collections of snowflakes started to emerge. The first one was by William Alwyn Bentley in the late 19th century. He, by the way, termed the phrase that no two snowflakes are alike. Since then, scientists have come up with different classification schemes to classify these different types of snowflakes, or different type of snowflake shapes. So, for example, in 1966, there was one where they divided snowflake shapes into 8 classes, each having different subclasses, so in total 80 different types of snowflakes. There's also a newer one by a Japanese research group from 2013, where they have in total 121 different types of snowflake classes. Now, that's quite a lot, and we can simplify that quite a lot. So, in general, snowflake shape is hexagonal, and then you can either have snowflakes that grow along the sides, so in a kind of plate-like shape, or you have this hexagonal base and it grows along top and bottom, so in a column-like shape. So that's the two kind of shapes that we can discriminate. And if we have a plate-like shape, along the edges of our hexagonal base, branches can form. And from these branches, again, sub-branches. And that's where we get this very typical snowflake shape, like that one you probably pictured. In science, we call that shape dendrite. So this is a dendrite ice crystal or dendrite snowflake. To understand why the base shape is always hexagonal, we have to do a bit of chemistry. But don't worry, only a tiny bit. I myself have like 0 background in chemistry, but it's super easy to understand, I promise. I'm sure you've seen this sketch of a water molecule before. So you have the oxygen atom in the middle and then the 2 hydrogen atoms to the sides, forming this almost triangle-like shape. You probably also heard in some kind of basic chemistry class that the oxygen has a negative and the 2 hydrogen atoms a positive charge. Then when water freezes, a lot of these hydrogen molecules align themselves in a crystalline grid shape. And because opposites attract, the hydrogen atoms like to attach themselves to the oxygen, and there you automatically get this hexagonal grid shape. Our ice crystal, which consists of this hexagonal grid, can then grow by more water molecules attaching to it. And then can be done either by attaching them to the sides or to top and bottom. So there you get either this plate-like or this column-like shape. Because if you have this plate-like shape, the edges of the hexagonal structure stick out a bit more. It's easier for the water molecules to attach themselves there. And then you get branches forming, because then once the molecule has attached itself there, it sticks out even a bit further, and so it's easier to attach. And you can get sub-branches if you again have some kind of places where the molecule sticks out a bit more, and so it's easier to attach there. In what direction the snowflake grows, so either to the side or top or bottom, depends on temperature and humidity. There's this very famous diagram where you have temperature on the x-axis and humidity on the y-axis. Don't worry, this is the only kind of scientific diagram that I'm showing here. Here you can see that at what we call warm temperatures, so close to 0 degrees Celsius, the blade-like growth is preferred. But then when you get to a bit colder temperatures, so at about -5 degrees Celsius, column-like growth is preferred. And if you have very high humidity, you get these very thin, long ice crystals, which we call needles. Like, stick them with the pointy end needle, sorry. And if we're going even colder temperatures, so about -10 degrees Celsius, then plate-like growth is preferred again. And here at about -15 degrees Celsius, you get these really large, pretty dendrite snowflakes. So when I saw these ones at the ground, I think I took the picture in Longyearbyen, in Svalbard, 1.5 years ago. It was maybe -15 degrees up there in the cloud where they came from. Also take a look maybe next time it snows. If it's rather warm at the ground, so close to 0 degrees, you might be able to see these long fin-like needle shape, maybe them also sticking together. That works best when you have, like I do in this picture, a dark woolen glove or maybe a dark black jacket. There you can really see then the individual snowflakes sticking onto there. And I say warm temperatures at the ground because keep in mind, if we go further up into the atmosphere, it's likely that it's colder. So if it's -5 degrees up there, it could be that it's close to 0 degrees down at the surface. I already mentioned individual snowflakes can also stick together, forming what we call aggregates. That's what's very common. So if you have these huge fluffy snowflakes falling down, these can consist of up to thousands of individual ice crystals. Also, pieces can break off from the snowflake. And that's where you come to the point where I'm a bit of a hypocrite, because there you can very well get a 5-sided snowflakes, even though I would say that's wrong. Snowflakes are always 6-sided. But as you can see in the picture I've shown already, here for example, one of these branches broke off and you suddenly get a 5-sided snowflake. So nature doesn't really care what's right or wrong. And you can get whatever that is, or this one. Here's also a fun one. I call that one the TIE Fighter. But still, when you draw a kind of perfect snowflake shape and it looks like that, sorry, but that's just wrong. How snowflakes look like tells us a lot about their history, so what kind of temperature they experience during their growth. So for example, you can get these cool looking snowflakes, which first started to grow as columns, so temperature range of about -5 degrees Celsius, but then they went to a different kind of temperature range, so either warmer or cooler, and started to grow in a plate-like regime, getting these plates on the edges, so that's what we call capped columns. About the question whether every snowflake is unique, yes and no. So in nature, probably every snowflake undergoes slightly different conditions, so slightly different temperature and humidity conditions, making them unique in a sense. And even if you have snowflakes that look very, very similar because they grew under the same temperature and humidity conditions, once they stick together, forming an aggregate snowflake, which is probably the one then falling down to the ground, they align in slightly different orientations, slightly different angles, and so here we can say that probably every snowflake is unique. However, it's not impossible to create two snowflakes that are the same. So there's this US-American physicist called Kenneth Liebrecht who studies snowflakes, and has this really amazing lab setup where he can create what he calls designer snowflakes. So these are real snowflakes that he makes, but he can very precisely control temperature and humidity conditions to make them grow and look however he wants them to. And there he can make the same snowflake twice, just letting them exposed to the exact same conditions. So he calls these twin snowflakes. By the way, fun fact, he was also the official snowflake consultant on the Disney movie Frozen. On the topic of mixing art, if you want to call Frozen art, and science, there's also one more cool project I want to show you that's called Curiosity, and it's by Helene and Thomas Hoffmann. They spend some time in the Arctic and in Antarctica, and they collect and preserve snowflakes. So they collect them in a kind of glue-like mixture. To be honest, I have no idea what's in there. It's the secret trademark recipe, whatever. And they can then preserve the imprint of the snowflake. And that looks something like that. So that's a picture I took of one of those. And they have a lot more cool pictures on their webpage if you're interested. But just imagine, it looks so cool. If it would be a necklace, right? I really would want to have one of those. But don't take me seriously. Anyhow, we've reached the end for today. We are by far not done with snowflakes. As I teased in the beginning, I want to show you some really weird looking snowflake types next. So here's a little spoiler. You can see the picture here, and I will explain to you how these ice lollies, because that's what they're called, can form in nature. But I'm also open to doing different videos in between, so if you want me to talk about something specific, be it Arctic science or history related, or about field campaigns, or about day-to-day life as a researcher, as a PhD student, write it in the comments. I'm very open to doing a video about that. If you enjoyed today's video, please give me a like, write me a comment, tell me if you've learned something new. Keep an eye on snowflakes once you start to see them in nature. Subscribe, also so you don't miss out on the next videos. As I said, weird snowflakes are really cool. Alright, but thank you very much for watching. I am sorry about the voice, I'm still recovering from a cold. I know, very fitting for this channel, but I hope it was not too bad. Alright, stay safe, stay healthy, and see you soon. Bye bye!